Okay, let's try one more problem. Let's look at the square root of 63. So if we're trying to simplify the square root of 63, we have to see, okay, what number is the largest perfect square that is a factor of 63. So I'll look at my perfect squares again on the multiplication table. Well, if I'm just thinking about what numbers multiply to get 63, well, 3 goes into 63, and that's 21 times. 3 times 21 is 63. Or you can also do 9 times 7. So you can think about them that way, or you can look at this table and go in order and see, okay, which of these perfect squares, the highlighted numbers, divide evenly into 63. Does 1 go into 63? Well, of course. But is it the largest perfect square? Let's keep checking. Does 4 divide into 63? Well, no, it doesn't go into 63 evenly, and you could check that on a calculator if you weren't sure. See if you get an integer, a whole number. If you divide 63 over 4, does it give you a whole number? Well, you'll see it doesn't. Okay, does 9 go into 63? Well, yes, we just said that. 9 times 7 is 63. So 9 is a perfect square that goes in evenly into 63. Is it the largest? Well, let's keep checking. Okay, and if you kept checking 16, 25, 36, 49, 64, none of those go evenly into 63. So the largest perfect square that divides into 63 will be 9. So what I'm going to do is I'm going to rewrite 63 as the product of 9 and 7. Because 9 times 7 equals 63. What that's going to, pardon me, what that's going to allow me to do is break this up into square root of 9 times square root of 7. And the reason we'll do that is because square root of 9 is a perfect square. I know what number times itself equals 9. It's a whole number, it's 3. So I can rewrite 9 as 3. Square root of 7 is an irrational number. It cannot be simplified into an integer, so that's the irrational part. We leave that by itself. We have a whole number and then an irrational number that we leave under the radical sign. So this is a cleaner way of writing it than putting it as a decimal. This is how you simplify the radical.